So welcome again. Today we're going to talk about merge sort algorithm. So welcome back again to the series of 100 days DSA mastery course. And today is the merge sort algorithm. So this is day 4 and today we're going to do like the merge sort as it sounds. It's really interesting algorithm to perform. So let's just see the basic definition of what exactly is merge sort algorithm. We'll see the theoreticals and then we'll move on to the practicals as usual. Let's just do that real quick. All right, so the merge sort is a classic, efficient, and versatile sorting algorithm that uses the divide and conquer strategy to sort elements. You heard me, the divide and conquer strategy to sort elements. It is mostly commonly used algorithm due to its stability and predictable performance, making it suitable for large data sets and complex sorting tasks. So this is one of the first one which is really efficient and good for when it comes to large data sets and complex sorting data sets. So far we have learned all the algorithms which were inefficient and were unable to work with large data set, but merge sort can actually work with large data sets. So this is going to be an interesting one. Let's just look at what exactly is the step of performing a merge sort algorithm. So there are basically 3 steps: divide the array, conquer by sorting, and merge the sorted sub arrays. That's it. That's all we have to do. First, we have to split the array into 2 halves, which creates each sub arrays which will have just single element. Then we'll conquer by sorting. Recursively sort each sub array. And then what we do is merge the sorted sub arrays. Combine the 2 sorted half into one single sorted array. That's how it works. Simple as that. So if it sounds really complicated or if it sounds like really complex or something, then let's just do the practicals and you'll understand what exactly I'm talking about. So the first thing that we do, as usual, just create a function. All right. Okay, so the function will be named as merge sort, and the argument, as always, array. So the first thing that we do is take the length of the array and see if it's greater than 0 or not. All right, then what we do is find the middle of the array. Find the middle of the array. And how do we do that? By dividing the length of the array by 2. That's it, simple as that. And that's how we find the middle value of the array. Once we have that, let's just divide the array into 2. Like we have the left half and the right half, right? So on the left side, on the left side of the mid, there will be the left half, and from on the right side of the mid, there will be the right half. So what we do is just merge sort the left half and right half. So this is like the recursion stuff. Recursively sort the first and second half. All right, the function calls itself. All right, so now what we do is define 3 variables and give them a default value. I'll just keep it to 0 because that's how the logic actually works, because we have to keep it 0. Then what we do is just copy data to temp arrays. All right, we'll have temporary arrays in which we'll copy the data, like the left half and the right half. Okay, all right. So how do you do that? By while then we'll say if, then we'll say if the right half is okay, if the right half is greater than the left half, then what we do is assign the left half value to the array of k, right? That's how the logic shall work. Okay, let's just do that real quick. Okay, j, and then what we do is simply say k is equal to left half of I. Done. Now what do we say then? I, and then we'll increment the value of I. And if the left half is not, if the left half is not smaller than the right half, then what we do is array of k will be assigned as right half. Simple as that. right? Okay, so it will start the sorting of the data. Now if you just take a look at the, like, if you were to do a dry run of what exactly the statement is, if you were to, like, create a random pictorial representation of what are we doing right here right now, you will actually see it in real time that we are just sorting the data, we're just swapping it. As I already said, every single algorithm related to sorting is just swapping. The logic is just different, the approach is different, the protocols are different, but exactly all it comes down to is just swapping the numbers with one another. It's just same, exactly same. Now let's see. So why do we use the another while loop? Another while loop is to check if any element was left, whether all elements are sorted or any elements is left or not. Let's just check that real quick. And once we done checking both the sides, like left and the right one, all we have is just creating the array. That's it. So let's just do the same thing for this part. Right, done. And just say j plus is equal to 1 and then k plus is equal to 1. That's it. That's all we have to do. Just see how it goes. So we'll just have a bunch of different random data up here, like the random numbers that we want to be in the sorted order. Okay, so we're done with it. Now what do we do is just merge the, okay, let's just say we do the sortings. So here we are done. So let's just return the array because we want the output. That's why we have to return the array. Once we are done with that, let's just run this program and see how that goes. And you can see there is your output pretty perfectly fine. That's how the merge sort. You'll find all the code into my GitHub. So just go and go onto the description and click on the link and you'll find yourself on my GitHub where you can download all the code that is available on this course. Thanks for watching.